Okay, good morning, class. Can you guys hear? Can you see the screen?
Yes, sir.
Yes, sir.
Sir.
Just give me a few seconds. Let me get some water. Okay, so today we're going to talk about circular motion and more specifically cars and trains and why they flip and skid, things like that. But more or less it's still circular motion. Now, one thing we can remember from last class, from last class is that centripetal force F, right? Call F the centripetal force, may put a sub C for that, is equal to M, which is the mass of the body, times V squared divided by R, right? Hopefully, everyone remembers this formula, right? Now from this, we can derive the other twos. I'll briefly go through them as we need them, right? Let's start right away with number 13, and we'll go over the formula and how it came about briefly. All right, good. So 13, a vehicle has a center of gravity of 1.06 meters above the ground, and the wheel track is 1.2 meters wide. Determine the minimum speed in kilometers per hour at which the car will overturn when rounding an unbanked curve of 4 to 5 meters in radius. So what does that mean? So unbanked refers to a flat road, right? Flat road. No kind of lift or anything. Like, I don't know if you guys have ever seen like NASCAR racetracks. The road is slightly tilted around in a circle. Okay, good. So now the formula we need for this is the maximum velocity formula, which is this. But where did this come from? Well, let's pretend we have some car here. Two little wheels here. And of course, that's lying on the road. It's lying on the road. Somewhere along the center line at 1.06 meters above the ground is its center of gravity, right? So center of gravity. Let's just put a little dot for that. Big G for center of gravity. Now, the centripetal force when a car is turning is provided by friction, right? Mu mg, right? In this case, that centripetal force is also mv squared divided by r, right? And sometimes the frictional force is not enough to keep the vehicle stable. Sometimes turning might cause it to switch the weight or shift the weight from one wheel to the other, right? And that's what's going to cause it to flip. So the weight of the vehicle, right, mg, is distributed between these two wheels, right? And the reactions from the ground are R1 and R2, right? So you can establish basic formulas like such as R1 plus R2 is equal to mg. Okay. And the distance between them, the distance here for the center of gravity is 1.06, or we could just say h, right? Distance is h from the ground. And the distance between these two is 1.2 meters, or we can just say a, right? A. This would allow us to establish a moments formula. Now what we do is we can take moments about a particular point, right? About this particular point, G, the center of gravity, and characterize all the forces. Now we know the centripetal force comes from friction, and the tires are contacting the ground. So this centripetal force here is actually coming out here, right? And we can call that F, right? So we can say something like this. R2 times the distance, the perpendicular distance from the center of gravity is A divided by 2, right? A upon 2 is equal to F, the centripetal force, times H, the perpendicular distance from point G. Remember, we're taking moments about a point, and it's not the same as taking moments about some horizontal beam or something like that, right? Get H plus the moments out from R1, from this force R1, which goes in the same direction as the F, right? So this F here will cause it to go this way. The force F clockwise, and R1 as well clockwise. But R2 is anti-clockwise, right? So R2 is equal to F plus R1, A divided by 2. And we establish this formula. Now, another thing is that when the car is about to flip, depending on which side we're turning, the weight shifts from being on both wheels to just one wheel, right? So the weight is going to come off of this wheel. So the car is going to start lifting up, right? So all of the weight is going to come off R2 or come off R1 and go on R2, right? Depending on which side you're turning. So if one of these are going to go to 0, so let's say this one goes to 0 because it's going to shift onto one wheel. So we're going to left with something like R2, which is of course mg A divided by 2, and F, which is mv squared R times H. Simplifying this, taking out the m's, we get GA divided by 2, or AG divided by 2, right? Same thing here. Multiplied by R, we take over the R. Divide by H, we take over the H. H is equal to V squared. So therefore, we end up with V is equal to the square root of AGR divided by 2H, which is what we have here. And this is just the form of a maximum velocity. And now for maximum radius, you just go ahead and rearrange that formula and solve for R. So that way we can know the maximum radius. The maximum radius, assuming a particular velocity. I think someone had a question while I was explaining something. Go ahead. Did anyone have a question or no?
I don't think so.
Okay. All right, so using this formula, which we just established briefly, and of course, if you want a little bit more intuition on it, you can go ahead and read the handout. And then they'll explain it better and put a lot of the details that I missed out inside. Okay, good. So a vehicle has a center of gravity of 1.06 meters above ground. The wheel track, which is the distance between the two wheels, right, is 1.2 meters wide. Determine the minimum speed in kilometers per hour at which the car will overturn when rounding an unbanked curve of 45 meters radius. So how do we do this? Well, we just simply plug the values in. A is 1.2. Okay. G is of course 9.81. R is of course 45 meters, which is the radius. Right? And the center of gravity, 2H, is 2 times 1.06. Plug this into a
Excuse me,
calculator. Yeah, go ahead.
sir.
Yeah.
Sorry to disturb, but you have determined the minimum speed. Isn't that supposed to be maximum speed?
Well, maximum speed a car can take a turn is minimum speed it will overturn when rounding an unbanked curve. It's like the maximum speed it could take without overturning. Max speed it can take without overturning, right? This would be max speed. It can take without overturning would be some value. Let's call that value V. And the minimum speed, and after all this, after all that, all of this here, it will overturn, right? Overturn. So the minimum speed it will overturn is right there, right? It's right there at that point. So this is the minimum speed it will overturn. Car will overturn. This here would be max speed, max velocity, where that the car could take the turn without overturning, right?
Yes, sir. I now understand what it's asking for. It's asking for the minimum overturn speed, meaning the lowest
Yeah.
speed is going to overturn that.
Yeah.
Also, sir, in your formula, you could explain why, is it like a similar reasoning for why you put max radius? Because the textbook have it as minimum radius.
Minimum radius. Really? Let me see. It's probably like the same thing. Let me just see. Tendency to skid. Yeah, minimum safe radius. Outside of that, that is the yeah, minimum safe radius. It's like yeah, it's
Thank you, the
kind
other
of like
one.
the same thing. Minimum safe radius, huh? I'm just formula. V squared over R. Yeah, it's like a similar reading, but the reason is the minimum safe radius is because if we increase R, right? If we increase R, the velocity obviously would increase. So that means with a bigger radius, right, going around the bigger turn, right, it's easier, right? It's easier because like the turn is more spread out. But if we decrease R, right, we decrease R, the velocity is going to go down, right? So going around a sharper turn, right, a sharper turn is harder and more likely to cause the car to flip, right? So that's just why there's a minimum safe radius.
All right, thank you, sir.
Safe radius. It just depends on what you're looking at. Okay, good, but yeah, just plug your values in, okay? Just plug all your values in, put them into a calculator, and you should get 15.807 meters per second. But remember, determine minimum speed in kilometers per hour, right? Kilometers per hour. So we need to convert this. Now, in order to convert this, we're gonna have to multiply by 3.6, right? The reason for that is because we're 1 second is 600 hours and 1 meter is 1 upon 1,000 kilometers, right? So we just that's the same as would be multiplying by 3.6 because it's 3600 divided by 1000, right? So we just multiply by 3.6 and you get 56.905 kilometers per hour. All right, good. Any questions?
No, sir.
Good. Okay. So for this question, explain why there must be a radial force acting on a body which moves with a uniform velocity in a circle. So for a body to move in a circle, there needs to be some kind of radial force, which is a force in the direction of the center, right? Pulling towards center, some kind of centripetal force, right? There must be some radial force. And technically that's just perpendicular to that tangential velocity at any point, right? Now, the reason for this is in order to constantly keep changing this velocity by changing it from here, from that direction to that direction, and to this direction, and so on and so forth, around the circle, keeping it turning, right? We need this force to apply that acceleration. And we know acceleration is the change in velocity. It's what changes that velocity. We need this radial force to accelerate the body in different directions, affecting the direction of velocity. So that's the purpose of that. Now, I think the textbook has a nice diagram explaining where this formula comes from, so I'll go ahead and just use that. Okay. So now, banking of the roads, right? Remember, banking is, as I was saying, with like a NASCAR track. Let me see if I can get a picture. Yeah, you see how the side of the road is elevated in slightly? It's like moving up. It has a slope. That's essentially what they're talking about with banked and unbanked roads. Okay. Now with a banked road, we see something different happening, right? We see the mass from the center of gravity. Remember, the mass is going to be acting from the center of gravity directly downwards. Straight down. So this here is your mg, right? Your mg, right? Now, because of that, right? The same way when we were doing inclined planes and things like that, this mass can be broken up into two components now, right? One of that component is mg tan theta, assuming there's some angle. And this angle, we could remember from inclined planes, is related to this angle, which is the angle how much elevation the road has, right? So this theta here is the same as this theta here. See if I can zoom in even further. Right? This theta here is the same as this theta here. Right? So this here would be the opposite.
Can see. Can see
Sir,
your
the
screen,
screen
sir.
went off.
Can you
Your
stop sharing, sir?
screen went off.
Oh, sorry. Yeah, accidentally probably pressed stop share. Yeah. So this theta here, as we're saying, so this line here, this is your mg. This theta is the same as this theta. We remember that. If you don't remember, you can think it through and figure it out for yourself. Now this part here is mg tan theta, and that just comes from trigonometry, right? This here is the opposite. This here would be the opposite. So tan theta is equal to that opposite over the adjacent, right? And adjacent is what we have as mg. So we just carry over the adjacent and end up with mg tan theta. Okay, Now this one with mg sec theta, or you can say mg 1 upon cosine theta. I prefer that, honestly, instead of just having to explain what sec is. But sec, they're essentially just the reciprocals of the sine and cosine and tangent functions, right? Just some new trigonometric functions, which you may have covered in math already. Good, so for this one, right, this here is the hypotenuse. So cosine theta is equal to this thing, right? The hypotenuse divided by mg, right? mg. So if we flip it, we'll end up with 1 upon cosine theta is equal to mg is equal to the hypotenuse, sorry, which is what we're looking for, divided by mg. So mg, 1 upon cosine theta, or sec theta, is equal to the hypotenuse, which is this value. So we end up with those two formulas. Okay, now the centripetal force is gonna come from the horizontal component, right? Right, the component acting here. That's where that centripetal force is gonna come from. So we can just easily establish that mg tan theta is equal to our m v squared over r. Of course, cancel out our m's, carry over the g, and we'll end up with something like this, right? So mg tan theta, cancel out the m's, carry over the g, we end up with tan theta is equal to v squared gr. And from there, we can continue on the question. Okay. Okay. So tan theta is equal to v squared. Okay, good. So our railway on a curve of 800 meters radius has a gauge of 1.4 meters. By how much must the outer rail be raised, right? That's the banking, right? So the thing, how much must this rail here be raised, right? What level? Let's say L or H, right? How much must it be raised? If there is to be no side thrust on the wheels at 70 kilometers per hour, at 72 kilometers per hour. So we apply that formula, tan theta is equal to v squared on gr. To find the angle, okay?
I want to mean by side thrust.
Be no side thrust on the wheels. It's like, it's kind of like skidding, yeah?
I got you, sir. I got you.
Yeah. Yeah, so like, usually when you go around the turn, if you go around it too fast, the car becomes a bit unstable. And generally two things might happen. The car might oversteer and understeer. So if it understeers, it would kind of like start sliding. And it would, instead of making the turn, it would kind of not turn for some reason and kind of slide off the track, right? And that just depends on how the car is balanced and designed. Or something, another thing would happen is oversteer, which is it would kind of steer too much and it would kind of turn this way. And next thing you know, right? So this is the front of the car, then this is the front of the car, this is the front of the car. And instead of continuing along this way, right, you end up spinning all the way around, right? Pointing back this way. So you kind of lose control of the vehicle. Okay. So plugging those values in, right? We get tan theta is equal to b squared divided by gr. We need to convert this into meters per second. So how do we do that? Divide by 1,000. I'm sorry, multiply by 1,000 and divide by 3,600, right? And we get 20 meters per second. Squared divided by 9.81 times 800 meters. Okay, plug this into a calculator, you should get 0.05097. The tan inverse of that should give you theta as 2.918 degrees or 2.92 degrees. Now using that, right, we can find the height that needs to be raised because the gauge is 1.4 meters. Right, so here to here, 1.4 meters. The angle, we know that this here is the opposite. So sine of this value, theta, is equal to whatever this is. Let's call it L or H, right? H over the hypotenuse, right? Which is 1.4. So we just multiply 1.4 sine theta. And we should end up with a value like height raised is equal to 0.0713 meters or 7 to 1 millimeters. Okay, any questions on number 15?
No, sir.
Wait, so is what the height would be equal to?
Yeah, I'm sorry, I didn't hear what you were saying. Plane was flying.
What would the height be in terms of like in the sine equal opposite to the hypotenuse? Sine would be
It'll be the
Really?
height. The outer rail is raised, right? So what do you mean? What'll the height be? The height will be the opposite.
oh okay.
So it's like, how much must this be raised by, right? Because remember it's flat and you raise it up, right? Depending on what you want to accomplish. Various levels based on the angle. So the height is this opposite. Any more questions? Okay, so this one's easy, and I think you guys can do it. An electric tram car turns a sharp corner of mean radius 9 meters at a speed of 16 kilometers per hour. The road being horizontal, right? So none of that banking or none of that raising, right? Elevation. Find the greatest height of the center of gravity in order that the inner wheels may not leave the rails, right? The gauge is 1.37 meters. So for the inner wheels to not leave the rails, right? What that's talking about is not flipping, right? Is not transferring all of the weight to one of the wheels and having this one raise up and the car flip, right? Flip. So we're talking about that same situation where the car is about to overturn. So what's the max velocity, or based on this velocity, what's the max height, right? What's the maximum height based on this velocity? So we just use the maximum velocity formula and maneuver it to get the value for height, right? So I think you guys should be able to do this. So take a few minutes to do it. Just carry over, square this. Remove your sine, solve for h, put your values in, right? And plug it into the calculator, right? So take 5-10 minutes, do this. And if you have any questions, let me know.
Sir, could mute Jahim.
Okay, so did everyone get this answer?
Yes, sir.
Okay, good. So nothing
Yes,
difficult.
sir, I got that.
Just rearrange your formula, solving for H. Okay, good. So the next part, 17, derive an expression for the acceleration of a body moving with constant speed in a circular path. Now, this can be found in the first 2 pages of the handout, right? So you can just go ahead and look at that right there. Should be something like A is equal to V squared upon R, right? So you can just go ahead and look at how that's derived. Good. Now on to the actual question. A motor car is traveling around a flat circular track of radius 9 meters at 24 kilometers per hour and is just on the point of skidding. What is the coefficient of friction between the wheels and the road? So if it's just on the point of skidding, what that means is that the centripetal force and the force that comes about from the weight of the car and the weight of the vehicle being pressed down onto the road, right? Based on a particular coefficient of friction, that frictional force is up just about that centripetal force, right? So the frictional force is keeping it this way, and the centripetal force is pulling it back. And the vehicle is going to start skidding, right? It's going to start skidding when this centripetal force overcomes this frictional force. So if centripetal force A or C is greater than frictional force, let's say FR, this vehicle is going to skid, right? So it's, for it to be just on the point of skidding, we just assume they're equal. Is any more centripetal force, it's going to cause the vehicle to go out of control because we don't have enough friction or traction to keep the vehicle stable. So mv squared over r is equal to mu mg, right? Mu mg. Mu times the force as a result of gravity, right? Mu mg, which you guys remember from last semester. Plugging our values in, right? Of course, m could cancel out with m. Okay. Even though they didn't give us the mass, we know it cancels out because it's the same mass either way. And then we put g in, the radius is 9 meters. Gravity is 9.81. The velocity, of course, we need to convert this, right? Convert to meters per second, and we should get 6.667. We square that, finding mu, or coefficient of friction. Of friction to be mu is equal to 0.503, right? I remember coefficient of friction is unitless. Unitless. So it's not 0.503 meters per second or kgm squared, nothing like that. It's unitless, right? It's just the coefficient. Good. So any questions on that? No, right? As long as you establish formula, make that realization that friction and centripetal force should be equal. If it's just on the point of skidding, right? Then you can just solve for mu, and it's easy from there on. Okay, so number 22.
F is equal to mu mg.
Yeah, mu mg. F is equal to mu mg. Centripetal force equal to mu mg. And frictional force, if you remember from last semester, is that F, let's say R for friction, is equal to mu times the force normal, right? Normal is normal force, right? That as the weight of the body, which is mg. So number 22. A four-wheeled, two-axled vehicle travels at a uniform speed of 56 kilometers per hour around the horizontal curve of 120 meters in radius. The distance between the wheel tracks is 1.8 meters. The center of gravity of the vehicle is on the vertical through the center of the wheelbase and 1.5 meters above the ground. So H here is 1.5 and A here is 1.8. Okay. The total mass of the vehicle is 16 tons, which is 16,000 kilograms. Determine A, the vehicle pressure, not vehicle, the vertical pressure. What they're referring to here is just force, not pressure by area. We don't know the dimensions of the wheels, right, of the tires and whatever. So they're talking about force here. Determine A, the vertical pressure on each of the inner and outer wheels, and B, the maximum velocity at which the vehicle can negotiate the curve without overturning, right? So first things first, let's go ahead and find centripetal force, right? Now, we know the vehicle is traveling at a certain speed, and we know we can find these forces on these different tires by using moments, right? So if we go ahead and find centripetal force, then we can use our same moments equation that we were developing when we were developing this formula here for number 13, and just plug our values in, right? So centripetal force, mv squared over r. Of course, we need to convert this into meters per second. So 56 kilometers per hour is equal to 15.556 meters per second, converting that. M, 16 tons is actually 16,000 kg divided by 120 meters, which is the radius of the track. Plugging those values into our calculator, we should get the centripetal force is equal to 32,265 newtons, or 32.26 kilonewtons. 32.26 kilonewtons. Now, from that, we establish our little moments equation. Okay. We have our little car here. Right, the center of gravity is 1.5 meters above the ground, right? So 1.5 meters above the ground, right? That's where this F is going to be acting. 1.5, right? This here is F, going that way. Then from here, we're going to have R1 and R2. Just depend on which direction you turn in. Could change them, right? And their distances are going to be A divided by 2, which is of course 1.8. A divided by 2 is equal to 1.8 divided by 2, which is equal to 0.9. You plug those in. And remember, the centripetal force along with one of these, R1 and R2, depending again which direction you're turning, gonna add up to the other one, right? So we'll end up with something like 0.9 R2, 0.9 R2 is equal to 0.9 R1 plus 1.5 F, where F is that centripetal force, right? And we calculated it here. Good. Now solving this, right, or rearranging it, we get 0.9 R2 minus 0.9 R1 is equal to 1.5 F. Factoring out 0.9, we get 0.9 times R1, R2 minus R1 is equal to 1.5 F, right? Now, F again is 32.26 kilonewtons, put that value in, multiply out, divide by 0.9, we should get R2 minus R1 is equal to 53.77 kilonewtons. And this is our first equation. Now, here we notice two unknowns, right? Two unknowns. So we need to find one and then use that one to solve for the other. Yeah. So now the weight of the vehicle, mg, is evenly distributed, or well, not evenly distributed, depending on how it's turning, is distributed among both wheels, right? So R1 and R2. So we can draw the conclusion that R1 plus R2 is equal to mg, right? Putting in the values for mg, m is 16 tons, which is 16,000 kilograms. G is 9.81. Multiplying that out, dividing by 1,000. You multiply this out and divide by 1,000, you get kilonewtons, right? We get R1 plus R2 is equal to 156.96 kilonewtons. Now, we end up with these two equations here and here. So we can just simply add them up, add these two equations, combine these two equations, right? And we'd end up with something like R2, 2R2 is equal to 156.96 kilonewtons plus 53.77 kilonewtons, right? So add those two up. You add those two up, you should get somewhere around like 200 and something. And then you divide by 2, you should get 105. Okay? So R2, after solving this equation, R2 is equal to 105.635 kilonewtons. But that there, remember R2.
Excuse, sir.
Yeah.
Before you go on, sir, you could just explain Magdam last step where you was adding, last track when you was adding.
Oh, we're adding the two equations. So you can just approach these two as like just simultaneous equations, right? This here and this here as simultaneous equations. Right?
Okay.
Yeah. So you just add them, or you can rearrange them and say R2 is this, right? R2 is this. So 2R2 is going to be this plus this. This R1 is going to cancel out with that R1. And you add these two, right? 2R2. Right?
Yes, sir.
Good. Or you can add them, just add them like straight away, just like that, right? And this R1. Yeah, this plus R1 is going to cancel out with this minus R1, and this plus R2 and this plus R2 going to add up. And this 53.77 kilonewtons and it's 156.96 kilonewtons are going to add up. So you'll end up with something like 2R2 is equal to this plus this. You add those up, divided by 2 to find R2, and you get R2 as 105.65 kilonewtons, right? Now remember, this thing has 4 wheels, right? So R2 refers to now the front wheel and also the corresponding back wheel. So what we need to do is divide by 2 to get the pressure, quote unquote pressure, but the force on one of the wheels, right? So we go ahead and divide it by 2. And you're left with R2, or the force on one of the wheels, is equal to 52.68 kilonewtons. Now, substituting this value back into one of the equations, anyone, right? Let's say this one, you substitute that 52 in, right? Solve for R1, we get R1 is equal to 51.595 kilonewtons. But again, that's between the front and back wheels on this corresponding side. So again, we need to divide by 2. So 51.595 kilonewtons divided by 2 is equal to 25.8 kilonewtons. Right, for one wheel. For one wheel. Okay, good. And that's that. Now, the question also asks, besides the vertical pressure on the inner and outer wheels, the maximum velocity at which the vehicle can negotiate the curve without overturning. So we have everything for this curve, right? Our max velocity formula, V is equal to square root of HER divided by 2H. We have everything. We have the height, which we know is 1.5. You have A, which is 1.8, that distance between them wheels. G, 9.81, the radius of the turn, which is 120. And 2 is just the number 2. Plug this into the calculator. You should get V is equal to 26.58 meters per second. Convert that into kilometers per hour, right? Multiply by 3.6. Right, 3600 seconds, 1 upon 1,000, divided by 1,000 kilometers. We get 95.7 kilometers per hour. Right. Now in the book, they had a mistake, right? Where the answer for 22 was 25.8 kilonewtons and 52.7 kilonewtons, which we got. But for that B part was 41.1 meters. And they asked for maximum velocity, right? So velocity can be in meters. So what happened was they accidentally calculated that minimum safe radius or that maximum radius, right, as 41.1, whatever. Right. So the book has a mistake for that question. This here is the correct answer, right? 95.7 kilometers per hour. Okay, good. So any questions overall, generally? I know a lot of the formulas might not feel intuitive, but it's up to you to, read the handout, watch some videos, do some simulations.
So I can please explain how I get the 95.7 km per hour.
You convert from this 26.58, right? So you put all your values into your formula, calculate it, and then you convert, right? How you convert, right? Seconds to hours, right? If this thing travels certain amount of distance in seconds, then in an hour, how much is it going to travel? 3,600 times that, right? Now the distance is traveled is no longer in meters, it's in kilometers, right? So 1 meter is equal to 1 divided by 1,000 kilometers, right? So we divide this by 1,000, which is 3.6. So we can just multiply this by 3.6 and we get this, right? We're converting units. Last semester.
All right, yes, sir. Yes, sir, that's not it.
Good. Any other questions? You guys have a test Thursday, right? Yeah, I would.
Yes, sir, we do.
Yeah, so it could either come on the pendulum stuff, right? It could either come on the pendulum stuff, or this stuff, right? I would recommend you study both. Pay a lot of attention to the pendulum stuff because it's more likely that some stuff on pendulum is going to come. But just still learn the formulas for this and have a basic understanding of how all these questions work, so that in case Miss does bring one of these, you'll be ready, right? Yeah, but focus on pendulum. Okay, any other questions? If not, you guys can leave. Okay, so that's all I have for you guys. You guys can go ahead and leave.
Sir.
Yeah.
Miss was saying there were some derivation of some formulas that we need to know.
For the pendulums?
Yes.
So what I think she's referring to is the stuff we covered last week, right? Like this stuff, right? Yes. Right, remember we did a whole thing where where the question said, no, not that one. Deduce an expression for height in a conical pendulum. And it was this formula but we had already done the derivation, which is this, right? So this is probably what she's referring to. But in the handout, there are some other derivations that you can look at, right? So be prepared.
All right, so we have to show the derivation, or we just have to work it out?
Depends on what the question asks, you know? If the question asks, show how this is equal to this, how vertical height is independent of mass and radius and length of string or something like that, then you would have to go about and derive this formula. It just depends on what the formula asks, right? You'll only know when you see the test.
All right, thanks. This was last week's work.
Yeah. Right? Remember, it's the same topic, motion in a circular path. So that's what the test is going to be on.
All right, thanks.
Yeah.
So the force for I think it's a centripetal force, FH. That's affected by the height because the greater height would make it easier to tip over.
The centripetal force is effect. Oh, for the cars, for the vehicles.
No, FH, like FH for the I'm watching the drawing, and I see that F, you'll multiply F by H, right? Is that because like the greater the height is the more force that would be applied to the direction when it's turning? And everything
Its moment would be greater, yeah. Its moment would be greater, yeah. Again, moments is just that force applied at some distance. So if the vehicle is higher, right? If it's like it has a higher center of gravity, right? Then the force is going to be applied on the wheels, right? So that's going to have a greater moment, causing this vehicle to possibly flip, right? And be like twisting this vehicle.
And it
Yeah.
doesn't matter which side we put it on, right?
Which side you turn the vehicle?
Yeah, it doesn't matter.
No, well, because we assume most of the vehicles are symmetrical, right? But for more like advanced analysis, you would have asymmetrical vehicle, right? You'd have an asymmetrical vehicle with wheels, and you would probably only have a driver, like a driver, right? They wouldn't have any passengers, right? Let's say a race car driver or something. So it'd be asymmetrical. So usually what you find is that they would put like a weight here, like a block, to counterbalance that, making the vehicle balance out on each side. But again, it just determines how far you go into this analysis of a vehicle, right? Yeah. But generally from this formula, right, maximum velocity, we can see if h goes up, right, bigger number, you divide it by a bigger number, this value overall would be smaller, right? So the maximum velocity would be lower, right? And the maximum velocity would be lower. So V is inversely proportional to h, right? Inversely proportional to h. So if you want to drive faster for your car, you want to lower it, right? You want to lower it. You want to drop your shocks, get some drop springs or something for your car. And that's why most like sports vehicles like Lamborghinis and stuff and Ferraris really are really low vehicles, right? They're really low, like just a little bit of space on the ground. And Formula One vehicles, like it's kind of like the driver sitting on the road because it's so flat, right? If you've ever seen that. Good. So yeah, that's all I have, you guys. You can leave. If you don't have any. Yeah.
Sorry, did you finish marking all the tests? Like the last
No.
test?
No, I still have a few more.
Oh, okay.
I will finish by Thursday though. So because you guys have another test coming in. So I'll finish before then for sure.
Yes, sir.
Good. All right, I'll send this handout and I'll upload this video as soon as I can. All right. Enjoy the rest of your day.